right, so in 5.5, we're going to talk about counting techniques. So essentially, we're figuring out the number of ways we can do different things. So the multiplication rule of counting says, if a task consists of a sequence of choices in which there are P selections for the first, Q selections for the second choice, R selections for the third, so on and so forth, then you're just going to multiply the P, Q, and R. So one of the great examples that's in every stats book has to do with clothing. So if you have 2 shirts and 3 pairs of pants and you assume everything matches and it's asking you how many outfits you can come up with, well, whenever you're talking about your shirts, you've got 2 options. So for your shirts, you have 2 options, and then for your pants, you have 3. Using the multiplication rule, we would just multiply here. And here we can see a diagram that this shirt goes with these 3 pairs of pants. So there's 3 outfits. This shirt goes with these 3 pairs of pants. There's another 3 outfits. So we would multiply, and we could add to that by saying that maybe we have 2 pairs of shoes. So if we added shoes to the equation, then we would still just multiply everything. So 2 times 3 times 2 would give us 12. But again, for this example, there was 6. So we use multiplication whenever there's a choice from group A and group B and group C. And we use addition when there's a choice from group A or group B or group C. So for instance, back to our picture with the 2 shirts and the 3 pairs of pants, if I said that you could pick one piece of clothing from either the shirts or the pants, well, now you only have 5 options. So we'll be adding these. So if it's talking about or, you're adding. If it's talking about and, you're multiplying. So here we have a woman has 5 blouses, 3 shirts, and assuming everything matches, how many different outfits can she wear? So again, blouses are going to be our first choice, and there's 5 of those. And then skirts are going to be the second category, and we've got 3 of those. We're going to multiply and get 15 outfits. For B, the outside of home, there's a keypad that can be used to open the garage if the correct 4-digit code is entered. How many codes are possible? So we get 4 digits, so we're going to have to go through and punch in 4 numbers. And then for each of these, it doesn't say that we cannot repeat, so we will assume that we can repeat numbers. Well, we're going to have 10 options in each of these. So we have the 0, 1, 2, all the way through 9. So this is going to be 10 choices. So we have 10 choices for the first digit, 10 for the second, 10 for the third, 10 for the fourth, or 10 to the fourth, which is going to be 10,000 different possible codes. And the probability of entering the correct code on the first try, assuming that the owner doesn't remember the code. Well, 1 try or 1 combination out of those 10,000 is going to be the probability. So this is not a very good probability that they're going to get it correct the first time. All right, for C, how many 4-letter code words are possible from the first 6 letters of the alphabet with no letter being repeated? Allow, and then also doing this, allowing letters to repeat. So we've got 4 letters that we're going to end up picking. And so this first is not allowing us to repeat. So for this first one, we're going to have all 6 letters to choose from. And then whatever letter we used, we cannot use again because we are not allowing repeats. So we'll have 5. And then we've used 2 letters, so we'll have 4 left to choose from. And then we've used 3, so we'll have 3 left to choose from. We're going to multiply that all together. And get 360. Now, if we are allowed to repeat letters, so this is without repeating. But if we are allowed to repeat, then we're going to have 6 choices for all 4 letters. And that's going to give us 1,296 choices. All right, now for D, stocks on the New York Stock Exchange. Companies whose stocks are listed on the New York Stock Exchange, the NYSE, have their company name represented by either 1, 2, or 3 letters. Repetition of letters is allowed. What's the maximum number of companies that can be listed on the New York Stock Exchange? Well, the first thing we need to remember is that there are 26 letters in the alphabet. So if we have 26 letters in the alphabet, then the options for having just one letter is just going to be the 26. So one letter, we're going to have 26 options. If we're using 2 letters, then for each of those letters, we're going to have 26. So we would multiply those together and get 676. And then for 3 letters, we're going to do 26, 26, and 26. Because again, 26 choices for each of these, or 26 options for each of these choices. And that's going to give us 17,576. And now, because we can have 1 letter or 2 letters or 3 letters, we're going to add all of these options together. And if we add those, we're going to get 18,276 options. So there's 18,276 possible companies that could be listed on the New York Stock Exchange. Okay, let's talk about the factorial symbol. So the factorial symbol is just an exclamation point. So if you see something like 3 exclamation point, this is red, 3 factorial. And what the factorial symbol means is you're going to take that number and every whole number below it down to 1 and multiply them all together. So 3 factorial is going to mean 3 times 2 times 1, and it's going to give us 6. So the things that we need to remember here is that the number that you're using has to be greater than 0, and it has to be a whole number. Or it can be 0 or greater, and it has to be a whole number. 0 factorial equals 1. So this is something you just got to memorize. 1 factorial equals 1, which hopefully makes sense. And again, that n factorial is taking that number and then every number below it down to 1 and multiplying them all together. So we could do 4 factorial is 4 times 3 times 2 times 1, or 24. All right, let's look at a traveling salesperson. So a traveling salesperson must travel to 8 cities to promote a new marketing campaign. How many different trips are possible if any route between cities is possible? So you've got 8 cities you're traveling to. So this first city, you're going to have 8 choices, because there's 8 of them. And then after you visited 1, you're going to have 7 cities left. And then after you visited those 2, you're going to have 6 left, and then 5. And hopefully you see that this is turning into a factorial. So this is the same as 8 factorial. And we can have our calculators do that. So we go 8, and then factorial's up here, so we're going to do shift, and then this x to the -1 button, hit equal, and get 40,320. And then for B, if we're arranging songs on a CD, so Dan's going to burn a CD that will contain 12 songs. In how many ways can Dan arrange the 12 songs on the CD? So this is, again, just going to be 12 factorial because you've got 12 choices for the first one, 11 for the second song, 10 for the third song, so on and so forth. So 12 factorial, and then we do that on our calculator. We're going to get this huge number. So this is going to be 479,001,600. All right, let's talk about permutations. So a permutation is an ordered arrangement in which R objects are chosen from n distinct or different objects, and repetition is not allowed. The symbol NPR represents the number of permutations of R objects selected from n objects. So this is where we'll be going through and giving lists. So this is super huge that whenever you're thinking about permutations, the order is important. And then also that we're not going to be repeating anything. So the formula for NPR is going to be n factorial over n minus r factorial. So let's jump in right quick. So if we had 7 people and we wanted to figure out all the ways that we could pick 2 people, where maybe the first person gets $100 and the second person gets $50. So where the order would matter. So we're going to have 7 factorial over 7 minus 2 factorial. Well, 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. So I can write that as 7 times 6 times, and then the 5, 4, 3, 2, 1, I'm going to rewrite as 5 factorial. And the reason I'm going to do that, so this 7 minus 2 factorial, this is 5 factorial. So now I have 7 times 6 times 5 factorial over 5 factorial, and those guys will cancel. So we're going to end up with just that 7 times 6, or 42. All right, so let's talk about A. So if you have 4 objects and you want to pick none of them, how many ways can you pick nothing? Hopefully, if you're thinking about it, there's only one way to pick nothing, and that's indeed to pick nothing. If we use the formula, we'd be doing 4 factorial over 4 minus 0 factorial, which is just 4 factorial over 4 factorial, or 1, because these will reduce. Now, I do want to show you that your calculator can do these also. So for the 7 pick 2, we can do 7, and then our pick is over here. So it's going to be shift, and then the multiplication. So 7, and then the NPR is above your multiplication symbol, so we're going to do shift, multiplication to get our P, and then 2, so this is our 7 pick 2, and there's our 42. For our 4 pick 0, it should give us our 1. And then for our last one, we have 7 pick 7. So it's asking us how many ways can we arrange those 7 items. And we're going to get 5,040. So again, 5,040. So for B, 4 members from a 20-person committee are to be selected randomly to serve as chairperson, vice chairperson, secretary, and treasurer. The first person selected is the chair, the second is the vice chair, the third is the secretary, and the fourth is the treasurer. How many different leadership structures are possible? So the order is going to matter here. So since the order matters, we're using a permutation. So we're going to have that 20 pick 4, because again, the order matters. So for the 20 pick 4, we're just going to pop it in our calculator right quick. So the 20 pick, so again, shift and multiply, 4. That's going to give us 116,280. So from just 4 people being chosen out of these 20, there's over 116,000 ways to do that. All right, so for C, we're going to list all the permutations of 5 objects, A, B, C, D, and E, taken 2 at a time without repetition. So again, permutation means that the order matters. So AB is different than BA. So we'll go through and list all of those guys. So we're going to have AB, AC, AD, AE, and then we need to pair B with everything. So BA, BC, BD, BE, and CA, CB, CD, CE, and D with everything. So DA, DB, DC, DE, and EA, EB, EC, and ED. So if we go through, we've ended up with 20 possibilities. And we do the 5 pick 2. So 5 and then shift multiply 2, we're going to get 20 also. And again, that's going to be 5 factorial over 5 minus 2 factorial, which is going to be 5 factorial over 3 factorial, and I can rewrite that as 5 times 4 times 3 factorial over 3 factorial, and then these guys will cancel out, and this will give us 20. Okay, so now let's talk about combinations. The big difference between combinations and permutations is that combinations is a collection without regard to order. So in this case, AB would be the same as BA. So we're just getting things in groups. So we're making collections or groups. So one of the ways that I always remember this is that combination locks, it's actually a horrible name. It's a lie. So it's not a combination lock because it would matter the order you put the numbers in. So it's really a permutation lock. So again, same rules are going to apply, that whenever we're going through and doing the NCR, that it's n distinct objects taken R at a time. And again, order is not important for a combination. So we've got to divide out the repeats. And to do that, we're going to have the n factorial over the n minus r factorial, just like the permutations, but then we're also dividing by r factorial. So here on A, this 9 choose 2 would be 9 factorial over 2 factorial times 9 minus 2 factorial. So we're going to have 9 factorial over 2 factorial times 7 factorial. And I can rewrite this 9 factorial as 9 times 8 times 7 factorial all over 2 factorial times 7 factorial. These 7 factorials cancel, and the 9 times 8 over 2 factorial, which 2 factorial is just 2 times 1, or just 2, is going to give us 36. And then I want us to think about 52 choose 1, so the second part of A. So 52 choose 1 is asking us how many ways we can choose one item from 52 of them. Well, we're going to pick them one at a time, and we would have 52 ways to do that. So we're going to pick them one at a time, and we would have 52 ways to do that. And then for this 40 choose 40, well, because the order doesn't matter, it's asking out of 40, how can we group 40? Well, there's only one way, and that's going to be the group of all 40. So this should be 1. And again, our calculators can also do combinations. So we would do 9, shift, and then we're going to use our division symbol. So the NCR that's above the division symbol. So 9, shift, division, 2. So our 9 choose 2. It's going to give us 36. Our 52 choose 1. It's going to give us 52. And then our 40 choose 40 is going to give us 1. All right, let's look at B. So how many different simple random samples of size 7 can be obtained from a population whose size is 100? So we're just getting a random sample of size 7, which means that it's just a group. There's no different treatment for the first thing chosen versus the second. So we're going to have 100, choose, because it's a combination since the order does not matter, 100 choose 7. So we'll just pop in our calculator right quick. So 100 choose 7 is going to give us this huge number. All right, so let's talk about this huge number. So this is what our calculator spits out. So this 1.600, this nice long decimal, times 10 to the 10th. Well, what this means is to move your decimal 10 spaces to the right. So if we're here, and we want to move 10 spaces to the right. 1, 2, 3, 4, 5, 6, 7, 8. We need to move 2 more. So 9, 10, and we're going to have to fill in with zeros. So it's going to give us this answer up here. So 16,07,560,800 for our answer. All right, and then for C, So this is very similar to the last problem on the previous page, except now we're dealing with combinations. So now the order does not matter, which means that AB and BA would be considered the same thing. So we'll list all of the combinations. We'll pair A with everything. So AB, AC, AD, AE. Now we're going to pair B with everything. B was already paired with A. B will not pair with itself. So we're going to have BC, BD, and BE. Now we'll do C. C's already been paired with A and B, so CD, CE, and then we'll pair E. And E is only, now we're going to pair D. So now we're going to pair D. So D has been paired with A, B, and C so far, so D and E will go together. And those are all the combinations because E has been paired with everything at this point. So we've ended up with only 10 this way. And if we do 5C2, so 5 factorial over 2 factorial times 5 minus 2 factorial, which will be 5 factorial over 2 factorial times 3 factorial. This 5 factorial is the same as 5 times 4 times 3 factorial over 2 factorial times 3 factorial. The 3 factorials will cancel. So we have 5 times 4 over 2 factorial. Remember, 2 factorial is just 2 times 1 or just 2. So this is 20 over 2 or 10. All right, let's talk about computing probabilities that are going to involve permutations and combinations. And for these two options, we're going to just use combinations. So for A, we have a packing error. So through a manufacturing error, 3 cans marked regular soda were accidentally filled with diet soda and placed into a 12-pack. Suppose that 3 cans are randomly selected from the 12-pack. All right, so let's organize our data. So for our total, we have 12 cans. And then those 12 cans can be separated out into diet and regular. So for the diet, they goofed, and we have 3 that are filled with diet. And then for the regular, it's going to be the remaining 9. So the remaining 9 for the regular. And so it's asking us to determine the probability that exactly 2 contain diet soda. Well, if we look at this in groups, we have a group of 3 of diets and a group of 9 of regulars. And it tells us that we are picking 3 cans. So for part A, we're going to pick 3 cans, and we want 2 to be diet. So we're going to pick 2 diet and 1 regular. So for A, it's wanting us to determine the probability that exactly 2 contain diet soda. So that's wanting us to select 2 diets and 1 regular, because we're choosing 3 in total. So of the 3 diets, we need to choose 2, and of the 9 regulars, we need to choose 1. So the number of ways to do that is going to be 3 choose 2 times 9 choose 1. So this is the number of ways to choose those 2 diets, and this is the number of ways to choose the 1 regular. And then we're going to divide that by the total number of ways to select 3 cans out of the 12. So that's going to be 12 choose 3. And this will give us the probability. The things to make a note of here: this 3 and this 9 are going to total up to this 12. And this 2 and this 1 are going to total up to this 3. So the first numbers on top will total to the first number on bottom. The second numbers on top will total to the second number on bottom. So to put this in your calculator, make sure that you're in mode 1, so just your regular mode. We're going to do a fraction, and then we're going to do 3 choose 2, so 3 choose 2 times 9 choose 1. And we're dividing that by 12. Choose 3. And this is going to give us 0.12 and then 272727. So we're just going to go out 4 decimal places and call that 0.1227 for the probability of selecting exactly 2 diets. So we're going to go through these exact same types of ideas for Part B and for Part C. So for Part B, it wants us to go and choose exactly 1 diet soda. So for B, we want to do 1 diet and 2 regulars. So of the 3 diet sodas, we need to choose 1. Of the 9 regular sodas, we need to choose 2. And again, we're still dividing by that 12, choose 3. So I'm just going to go back in and edit this. So the 9 choose 1 will become 9 choose 2. And the 3 choose 2 is going to become 3 choose 1. Of the 3 diets, we're choosing 1. And of the 9 regulars, we're choosing 2. And this is going to give us 0.4909090. So this will be 0.4909. And then for C, C wants us to go and pick all 3 diets. So this is getting a little bit less likely to happen than our first 2 examples. So for Part C, we want 3 diets and 0 regulars. So of the 3 diets, we're going to choose all 3 of those. Of the 9 regulars, we're going to choose none of them. And then again, dividing by that 12, choose 3 for the total number of ways to choose 3 cans out of the 12. So we'll pop back over. And this 3 choose 1 is going to become a 3 choose 3. 9 choose 0. And it's going to give us 0.004545. So this is going to be 0.0045. All right, let's look at our next example. So selecting a jury. So the grade appeals process at a university requires that a jury be structured by selecting 5 individuals randomly from a pool of 8 students and 10 faculty. All right, let's organize our information. So we've got total. We have 8 students and 10 faculty. We're going to have 18 people. And then that can be split. So the students, there are 8. And the faculty, there are 10. So for Part A, it's asking us, what's the probability of selecting a jury of all students? Well, again, we're selecting 5 people in total. So of the 8 students, we want all 5 to come from that group. So 8 choose 5 times, and of the 10 faculty, we hope to choose none of them. And then we have 18 total, choosing 5. So this is all the ways to pick a group of 5 from the 18. And now we put this in our calculator. And we're going to get 0.0065. So not very likely. For B, it's fine. We will need to find the probability of selecting a jury of all faculty. So for B, of the 8 students, we don't want to choose any. Of the 10 faculty, we want to choose 5. And again, that's going to be over the 18, choose 5. So this is all the ways to make groups of 5 out of the 18. And we'll pop that in our calculator. And we're going to get 0.0294. And then for part C, what's the probability of selecting a jury of 2 students and 3 faculty? So for C, we want 2 students and 3 faculty. So of the 8 students, we want to choose 2. Of the 10 faculty, we want to choose 3. And again, dividing by that 18, choose 5. And we're going to get 0.39215, so 0.3922. All right, let's look at a lottery question. So this was actually question C. In Illinois lottery game, Little Lotto, an urn contains balls numbered 1 through 39. From this urn, 5 balls are randomly chosen without replacement. For a dollar bet, a player chooses one set of 5 numbers. To win, all 5 numbers must match those chosen from the urn. The order in which the balls are selected does not matter. What's the probability of winning Little Lotto with 1 ticket? Well, first, we need to figure out how many ways we can pick 5 balls with the numbers of 1 through 39. So of 39 objects, we're going to choose 5. So we're going to have 575,757. So this is the number of ways to choose 5 balls from these 39 for the 1 through 39. If you buy a ticket, you have one of those combinations. So there's almost 600,000 different combinations and you're purchasing one. So the probability of winning with 1 ticket is going to be 1 out of the 575,757.